Hello, and thank you for coming. No slides? This is especially for me, special treatment. So thank you for coming. I want to present to you today an evaluation framework for cold start techniques in large-scale production settings. Why? So it doesn't work? Okay. Okay. Why? Because it's hard. So evaluating a cold start is a hard task, complicated task, but luckily it's an achievable one. Okay. Doesn't work. Okay. So my name is Moran Haham, and I'm a machine learning manager in Outbrain. And I also have a master's degree from Ben-Gurion University. And I'm also a dog lover. The clicker doesn't really work, so bear with me here. Sorry about that. The clicker. But now I don't see anything. Well, okay. So the goal for the presentation today is to walk you through what motivated us to generate the cold start framework, allow you the opportunity to learn a new framework, and lastly, share with you some results that we had in production. So allow me to introduce the framework via Outbrain's business use case. So Outbrain is an online advertiser platform in which we recommend ads to users on news sites. So imagine that you are on CNN reading a sports article. We want to personalize the recommendations for you given the sports context of the article. And much like other large-scale recommender systems, we have a continuous flow of cold start items added to our platform every day. So we're talking about over nearly 500,000 of new items, cold start items that are added to the platform every day. And our models are expected to quickly learn and warm the items and display them in the optimal settings. As I'm sure most of you are aware, exploration is a costly affair, as when we are exploring, we are forced to display new items as opposed to the optimal items. And this is precisely what motivated us to generate this framework. We needed a fast way to research cold start. Okay? We designed the framework to maximize the research output because we needed to warm the items quickly and cheaply. And so, given the chance, how would you choose between two different exploration techniques? How would you rank 100 of them? I'll give you a few seconds. Well, the answer is it's a bit tricky, and here is why. So different than traditional machine learning research, where you typically have a static data set for training and evaluation, and only the thing that changes is the model setup and parameters. In cold start research, the model is static, but technically the data set is what changes. So essentially, what you're researching in cold start research is what set of observations are optimal to warm the items. And for this purpose, what we did is we created the framework. Our research framework consists from two steps. The first step is the offline step, in which we simulate many cold start techniques. We choose the best ones, and we move to the second step, which is the online A/B testing step. In this step, we designed a special A/B testing flow that allows us to evaluate the cold start effect on our model performance. So let's quickly jump right into the offline simulation. The offline simulation consists of 4 steps, the first one being the cold start simulation. So what we did there, we used historical past data, and we just plotted it from the timeline. And we use the simulator to mimic many exploration techniques. So each exploration techniques generate different training set for a model. So now we have many different training set. And for each training set, we train an individual model, keeping the model parameters static. Next, we want to evaluate and compare all of these models that we generated. For this evaluation, what we do is, again, use historical data. So we did a simple temporal split and used the last observations that we have for the items as the evaluation set. Now, last but not least, we want to choose the top-end models that we received and move on to the online A/B testing stage. Unfortunately, choosing the top-end is not so simple because we have an inherited trade-off between exploration and exploitation. So, as most of you will imagine, the more observation we give to warm the item, the better model performance we will get. But luckily for us, not all of the observations were created equally. So in a sense, we can subsample the observations without degrading the model performance significantly. So what did we do? Or given that information, how would you choose? Well, I can tell you what we tried to do. So effectively, what we did is we created a utilization curve to depict the trade-off between exploration and exploitation. So what you can see over here, you can think about it sort of like an ROC curve. So in the y-axis, what you have is the exploitation. We used relative information gain as a proxy for the model performance. And in the x-axis, you have the exploration. And in the exploration, what we mean is how many observations we need in order to warm the items. So given this utilization curve, we were able to quickly prune out suboptimal techniques and see the trade-off between exploration and exploitation for the other ones. And we use that to choose the best techniques to move to the online stage. So to summarize the offline evaluation, we know that offline evaluation of cold start is possible. It's also fairly cheap and doesn't cost us any revenue. Additionally, we can see offline an estimation of the trade-off between exploration and exploitation cost. Unfortunately, offline evaluation also has its limitations. And the biggest limitation of all is because we use historical data. So given that, we cannot simulate the effect the cold start will have on the probability of each item to be selected. So this selection feedback loop cannot be really simulated in an offline setup. For that, we needed to move to an A/B test setup. So I will ask you again, if you needed to design such an A/B test, how would you do it? Well, I'm sure most of you in your head thought, well, what's the issue, right? You can just split the items. Some items will get the treatment cold start and others will get the control or a different treatment. Well, unfortunately, this was not really an option for us because our item population is highly, highly skewed. And that would mean that we needed to commit many, many items in order to kind of cut through the noise and reach significant results in such an A/B test. And that effectively means that we might be sacrificing many, many items. As this was not an option for us, we thought about it and we decided to do both. So what we set up to do was to generate a specific A/B test flow that would give each of the cold start items both treatment exploration and control exploration. So let me walk you through this flow. What we have, it starts like a simple A/B test, but we have a user request. We need to generate recommendations for this user. In our case, it's a news article, and we need to generate our recommendations. Much like any other A/B test, we randomly split this request between treatment and control. And once we allocate the request to either treatment or control, it enters really like a siloed pipeline. So it's maybe worth mentioning that our models are online learners, and that means that we constantly update our models with the fresh data that is coming in from our recommendations. And in this case, what we do is say the request was allocated to the treatment, we generate treatment cold start, and we use this treatment cold start to update the specific model in this silo. And same goes to the control. So what we have right now is two isolated models that are updating from their own individual feedback loops. One gives a control exploration and one gives the treatment exploration. We monitor these models online, just like any other A/B test, but in this case, we can actually compare two different explorations on the same items, and we choose the best one and scale it across our network traffic. So last stage of the presentation, I would want to share with you some of our results It's important to say that we use this framework all the time, so this is a continuous research, and we keep on improving our cold start techniques in Outbrain. The way that we look at the online A/B testing results is basically, again, translating the trade-off between exploration and exploitation. For the A/B test setup, we translated it into an ROI. So ROI is return on investment, the investment being the exploration cost, and the return being the exploitation revenue. So this is an example of a single experiment that we had in which we invested the cost of 0.2% of revenue, and we made 8 times our investment, so 1.6%. So to summarize the presentation, we know that luckily we can evaluate cold start both online and offline. If we do it for an online A/B test, we need to do it in a dedicated manner and keep in mind that it's a costly affair. Luckily, some of the aspects of cold start can be evaluated offline and should be doing so, as it has almost zero cost and can quickly rapid up your research throughput. And lastly, there is really a lot of potential in continuous research for cold start, especially for large-scale recommenders, because we have a lot of new items and users that are added daily to our platform, and we quickly need to adapt and adjust for them. So thank you for taking the time and listening to me today, and I would gladly answer all of your questions, either now or after or in Slido.
So far, just one clarification question, just about the focus on user cold start or item cold start?
Okay, this is a good question. So for us, the focus is usually on item cold start, but can be for many other the same.
And I was curious if you could say, when you're doing the A/B testing, like how deep through your systems do you have to split things? Like, is it just kind of on the algorithm level, or are there other things that kind of go through features and other parts that you also have to make a clean comparison?
So what we did is we split the user requests, just in terms of A/B test, and this we do for all of the A/B tests, but specifically for cold start, what we split is also the entire data flow, because online we do use online learners, so the entire feedback loop need to be isolated to don't have cross-contamination or like leakage of information.
Great. And does the probability of receiving control or treatment also get updated during the A/B test? Similar to a bandit approach, or do you keep it 50-50 through the whole test?
So we keep it 50-50 for the whole test, yeah.
And can you talk a little bit about how do you get like the exploration cold started typically? I know in the abstract you talked about giving preference to some new items, but I was just curious, like, how do you kind of normally get those new items into the system there?
So this is portrays more to the exploration techniques themselves. Mm-hmm. So we use many exploration techniques. So you can think about it from the most common ones like Thompson sampling or different confidence-bound metrics that we've tried. But now we are doing some more complex, let's say, proprietary confidence metrics. Yeah.
Great. All right. Thanks again for your talk.